Hello, and welcome to Ocean Academe Calculus 12. Finding linear approximation. Example. Given f of x equals the cube root of 2 plus x at the point x equals 0, find the linear approximation, Lx, of and use it to approximate the cube root of 2.2. What is the percentage error? So first of all, I want to rewrite this as 2 plus x to the power 1/3. So that's our f of x. Now our f prime x would be 1/3 times 2 plus x to the power negative 2/3. Now another way to write this would be 1 over 3 times 2 plus x to the 2/3. Now our linear approximation equals our function plus the derivative of that function multiplied by x minus xo. Now, this xo is our a. And what that means is our initial, or x equals 0. So, to express this another way, we take our function, which was the cube root of 2 plus, now instead of x, we're going to put in 0. This is plus our derivative, which was 1 over 3 times 2 plus, and again, instead of x, we're putting in 0, to the power 2/3, and this will be multiplied by x. Now just simplifying this, we've got the cube root of 2 plus 1 over 3 times 2 to the power 2/3 multiplied by x. Now we have to think to ourselves, how do we get this value here, the cube root of 2.2, when we have the cube root of 2? So from there we can determine that x equals 0.2. Now we just have to plug it in. So we've got our linear approximation, and we're determining that it's 0.2. Our x is 0.2. So this will equal the cube root of 2 plus 1 over 3 times 2 to the power 2/3. And instead of x, we write in 0.2. Multiplying this all out, we get a value of 1.3019. That's our linear approximation. Now we have to figure out what our percentage error would be. So we need to find out what our actual number is. And our actual would be the cube root of 2 plus 0.2. And we get a value of 1.300591. Now, in order to find our percentage error, we take our actual value minus our approximation divided by our actual multiplied by 100%. So plugging in our numbers, we have our actual of 1.300591, and we're subtracting the value that we got here, 1.3019. And that is over 1.300591. The percent that we get after all that is 0.1% error.